All right. So the factoring questions and the simplifying radicals. I think these are going to be some of the ones to look forward to on the quiz, actually. All right. So again, we're just looking for what these two terms. All right. We just want to know what they have in common. That's going to determine what we factor out. All right. Okay. A different color, maybe stand out. All right. So we want to identify the number and the variable that they have in common. So 8 and 12, they have a 4 in common. That's the biggest number that they have in common. And then as far as the x's go, this one has 2 x's, that one has 3. So the most that they have in common with each other is going to be 2. That's how many that each of them are able to give. All right, and then what we're going to do is like do the distributive property backwards. So 4x squared times something needs to give us 12x to the third power. That'll be a 3 to get 12. And then we need one x there, so that way x squared and an x will give us x to the third power. Okay. 4 times 2 will give us the 8. And we've already got an x squared, so we are done there. All right, at the end, if you want to, somehow check here, the idea is that 3x and the 2, they don't have anything else in common. So that does mean that we factored out the greatest common factor. Right. On this one, they have a 3 in common. You know what? I guess I'm thinking about factoring out a negative here. I don't remember if I factored out the negative or not, but I'm going to go ahead and factor out the negative. It may not show that in the key, but I'm going to factor out a negative because the one at the starting place is negative. So I'm going to factor out a negative. They have a 3 in common, and they both have an x in common. All right, but they don't both have a y. So this is all I'm going to be able to factor out here. So if I take away the negative, this term is going to now be positive, and it needs to be a 2 to give me a 6, and it needs to have an x to give me an x squared. Cool. All right. My sign here, the plus sign, will change because I'm dividing by -1 because I'm taking out a negative. And this, I'm just missing a y. All right. So 3x and a y will give us the 3xy there. All right, this one, you got 3 terms. We need to find something that goes into all 3 of them. All right, so they definitely all have an x in common. The most that all of them have, or I guess, yeah, something that at least all of them have is x to the third power. So we can definitely take out an x cubed. The number that they have in common. So let's say I'm going to just for the sake of argument, say I did this question wrong. Let's say I only brought out a 6x cubed. And if I brought out a 6x cubed, this first one would become a 10. And then, yep, just a 10. And it would be a minus 6x to the second power. X cubed, x squared. That'll give you x to the fifth. And then the last term, 6 times 2 would give you a 12. And I would have to have 4 x's to give me 7 total there. So the reason I know I did this question wrong is because the 10, the 6, and the 2, they still have some number in common. They still have something in common. The thing they have in common is a 2. So if I factor out another 2 out of this problem, since that's what they have in common, my 6 would just get multiplied by 2. So now I'd be factoring out a 12x cubed instead. And all I would have to do is cut these numbers in half. I'd have to divide them all by 2. So I'd get a 5, I'd get a 3x squared, and I'd get an x to the fourth, like that. Cool. All right, simplifying the radicals. So the trick here was that we wanted to pull out all the perfect squares that we can, any perfect square factor that we could. So that was the numbers like 4, 9, 16 was on there, 25, and sometimes even 49. But we just want to look for any of these numbers that will go into the radical. All right, so like for 90, 9 goes into it. So what I'm going to do is I'm going to take this number and I'm going to think of it as the square root of 9 and the square root of 10. And then the square root of 9, well, that's equal to 3. So my answer is going to be 3 square roots of 10. All right, the square root of 9 just turned into a 3. And that's what we do on all these. The 120, the perfect square there is going to be a 4. So this is going to be a 4 and a 30. All right, there's no other perfect square that will go into 30, like 25 won't, and 9 won't, and 4 won't. All right, so then the 4 is going to turn into a 2. Square root of 4 is equal to 2. And that's where I can stop there. All right, the 8, that's just a 4 and a 2. And then the square root of 4, that turns into 2. The 98, this is where you're going to have to use that 49. So 98 is the same as 49 times 2. And then the square root of 49, that's equal to 7. So we get 7 root 2. 175, I can divide that one by 25. So it's 25 and 7. Okay. And then the square root of 25, that just breaks down into a 5. So I get 5 root 7. That's it. 27, that's 9 times 3. So I'm going to write it as a 9 and a 3. The 9 is going to end up, or the square root of 9 ends up turning into a 3. So I get 3 square roots of 3. And then the last one. All right, 48. Dang it. I guess I need some extra space down here. All right, so the 48, if you divided this by 4, you're going to get something like this. You're going to get 4 and a 12. So you would say, oh, the answer is going to be 2 square roots of 12. But the 12 still has a perfect square inside of it. And so we need to break it down one more time. 12 is going to be 4 times 3. So what I have now is 2 times 2 times root 3. All right. Or if you want to, root 4 times root 4, that's equal to 4. Anyway, that's 2 times 2 is 4. And then I still have that square root of 3 there. All right. The other way, if you want to break down the square root of 48 directly, it would just be, think of it as 16 times 3 if your brain works like that. And then this just becomes a 4, and that just stays the root 3. Awesome.